Now, you spent a lot of time in the previous chapter mastering force, right? Just like at the end of kinematics you had mastered velocity. But what did you find about velocity? You found that velocity alone was not a good enough representation of motion, right? Why? Because if I told you something is coming towards you with a velocity v, and if I didn't tell you whether it's a mosquito or a monster truck, then would it really help you, the velocity v? But then what did you find? If you take that velocity v and multiply it with this quantity called mass, then you get a much more meaningful description of motion itself. And what did we call this product, mass into velocity? We called it the momentum, right? But now, the important thing here is, force alone is also not sometimes a good representation of what's happening. For example, I could be applying a lot of force on something, and if that body that I'm applying a force on doesn't move one bit, then am I really doing something? So the important thing we're bringing into the picture over here is the displacement of the body on which the force is being applied. In other words, more precisely, the point of application of the force. So then, I'm going to say something now, which is, if I apply a lot of force, and if the body on which the force is being applied doesn't move, I'm going to say that my force is not doing any work. Okay, there it is. I said the word, okay, work. But I want you to remember, this word work that I'm using here has nothing to do with your real life association with work. Yeah, I didn't go to work today. The speaker is not working. TV is not working. Yeah, none of that. I'm working out. None of that. So to avoid any confusion, I'm going to use this new word, physics work, together as fork, so that when we keep using the word fork, you keep remembering that this has got nothing to do with the usual work done. So now that I've introduced a new word for you, you will ask, what does this new word fork mean, right? And we'll get to that. Now let's say that I'm applying a very, very large force, as much as I can, on a wall. I'm stupid because I'm applying it on a wall, right? And nothing much is happening. And you know that this is very different from if I had applied the same force on a ball and given it a large amount of displacement, right? Something is different. So you want to capture that difference. Let's say I have a body over here, and I'm applying a force on it, as you can see. And no matter how much force I'm applying, this body is not moving, then I say that the work done by this force is 0. But if I do apply a force, and the body starts moving in the direction of the force, then I'm very, very happy. My force feels good and positive, that it's getting ahead in life. Then I say that the work done in this case, where the body is moving in the direction of the force, is positive. Yeah? But now, let's say that I bring it back over here, and now I'm applying the same force. Yeah, the same force F. But there's some force probably in the other direction, which is stronger, which is the only way that the body will end up going the other way, right? So let's say that I'm applying a force like this, but the body is going that way. Then what does my force feel like? It feels really down. Right? It feels really negative because it wants this body to go that way, but it's the exact opposite of what it wants in life is happening. So it feels like singing Linkin Park. I tried so hard and got so far, but in the end it doesn't even matter. I don't know if Linkin Park is still a thing among teens. I hear it is, so I'm just leaving it at that. But the force is going to feel negative, and I'm using that as a way to tell you that the work done here can be considered negative. So the idea is, if the force and the displacement are along the same direction, we call the work done positive, and if it's the opposite, we call it negative. And if nothing happens, then we call it 0. But let's get an intuition for this. What if I'm not doing that? I'm pulling this car at an angle like this, right? Like a child pulls a toy and walks, right? If I'm pulling it around and walking like that, and the car though is moving horizontally. So as you can see, now if I make it still, and you can see now, the force applied is at an angle like that, but the displacement is along a line like this. Now that's interesting, right? Because now you know from your idea of vectors that all of the force could not have been used to move, to displace this body. Yeah? Why? You take components of this force like this, you can see that this component, the vertical in this case, could have had nothing to do with moving the body horizontally, right? So if you had F, and if this angle was theta, then F sine theta would have had nothing to do with moving the body in this direction. It could not have, right? Because it's natural for that perpendicular components are independent of each other. Then, what is this force? It's F cos theta, and that's the only one that matters, right?